Welcome to 8.7. Now we're going to be plotting two or more lines on the same coordinate plane, and we're going to see if those lines are parallel or just intersecting. All right, so when you see three lines there, let's find the slope of all of them. So we're going to look for good intersections. I see some here. All right, I see some here. And I see some here. Okay, I could do some over here too. All right, and the top one, I go down, then I go over to the next one, and I get a slope of 1/2. I go down over there, I get the slope of 1/2, down over there, right? No matter what, they all have the same slope. The slope of all of them is 1/2. Are these lines parallel? Yes, they are parallel. What is parallel? Parallel are lines that will never intersect. Now, these don't intersect or cross while they're on the graph, but they don't ever intersect. These lines go on forever in both directions, and they'll never cross each other, and they'll never touch each other ever. And the word for that is parallel. Okay? And what we're going to learn today is that parallel lines always have the same slope, and it will work both ways. If lines have the same slope, they must be parallel. All right, so the lines on the left, this is what parallel looks like. Now they look parallel, but you will know that they are parallel when you calculate their slopes and that they are the same. These ones over here are intersecting, but they're a special intersecting. One of these lines has a slope of 1/2. The other one has a slope of -2. And in this case, these are not just intersecting, they form a 90-degree angle there. And when lines form a 90-degree angle, the angle is called a right angle, but the lines are called perpendicular. All right, so let's start with parallel lines. You should have heard about parallel lines before. So to verify these are parallel, we have to verify that they have the same slope. So this one has a slope of 2/5. The one on the bottom has a slope of 2/5. And if they both have the same slope, then they are parallel. All right, let's find the slope of both of these. All right, you don't have to do it in the same spot, right? So this is down 2, that's -2 for the rise, and a run of 3, down 2 and run. So they both have the same slope, -2/3. And so since they both have the same slope, they are parallel. All right, two lines drawn at a 90-degree angle is called a right angle, but the lines aren't called right lines. They're called perpendicular lines. All right, so this is a protractor, and it's how we're going to draw a 90-degree angle. So to draw a 90-degree angle, we're going to start here at this intersection and go straight up through 90. And that line is perpendicular. So this means right angle or 90 degrees. But the lines, we would call them perpendicular. If the lines meet at 89.9 degrees like that, they are not perpendicular. They are intersecting, but they are not perpendicular. All right, so we have to be able to look at these and tell which ones are perpendicular and which ones are intersecting. This little symbol is a dead giveaway that they're perpendicular. Now this is the classic picture, the blue is the classic picture of perpendicular. But if you take perpendicular lines and twist them a little bit, that red one is still perpendicular. You know that because you see the 90 degree. This little thing is an arc mark, by the way, and that indicates that angle is not 90 degrees as well. And so these are just intersecting, right? The perpendicular ones cross, right? They are intersecting. They're a special case of intersecting. They're intersecting at a 90 degree or right angle. The ones on the bottom are intersecting at a not 90 degree angle, right? This is less than 90. This is more than 90. Oh, and I should say this. When it's perpendicular, all 4 of these angles are 90. We just put the symbol in one of them, but they're all 90 degree angles. When it's intersecting, some are less than 90 and 2, and actually it always is 2 are less than 90 and 2 are more than 90. Okay. All right, so now as far as slope, right, this is lessons on slope. It turns out perpendicular lines are the negative reciprocal. All right, we know what's that? Well, we know what a reciprocal is. You flip it over, right? A negative reciprocal is with the opposite sign. So if one line is 7/4 and they're perpendicular, then the other one has to have a slope of -4/7. Let's try this one. So if one of them has -4/9, the other one has +9/4. I wish we called this the opposite reciprocal, but for whatever reason we don't. It's the negative reciprocal, but the other one could have a positive slope, but it's always the opposite and flipped over. It's both of those. If it doesn't have both of those, then it's not perpendicular. So what's the negative reciprocal of 1/6? Well, it would be 6/1 with a negative, but we don't write it that way. It's -6. So the negative reciprocal of -2, flip over -2, and you get -1/2, but then we have to make it the opposite, so it's the +1/2. So you'll notice in perpendicular lines, one of them will have a positive slope and one of them will have a negative slope. In all, there is one special case, but other than that, that is always true. Okay, so let's find these slopes and determine if they are perpendicular. Right, so I'm going to do this one, and I'm getting 2/5. Right, I'm going to do it over here, down 5/2. So one of them has a slope of -5/2. One has a slope of 2/5. Are they perpendicular? Yes, we know they're perpendicular when the slopes are negative reciprocals. All right, let's find these two slopes. I've given you the good intersections. This one is 3/2. This one is down, right? This is going down 2 and over 3. So -2/3 and +3/2 are the negative reciprocal of each other. And that means they're perpendicular. And what else does that mean? It means this is a 90-degree angle, and so is that, and that's a 90. All of those are 90-degree angles. Same thing here. All of these are 90-degree angles. We took a protractor on top of them, we'd see that. All right, so now let's combine basically everything we've learned in the lesson. So let's find the slope here, right? To find the slope without the graph, we're going to subtract our y coordinates and then subtract our x coordinates. Y coordinates give us the rise. So I'm going to do 2 minus 1, which is 1. I subtract my y coordinates. For my x coordinates, I'm going to do 5 minus 2, which is 3. So this first line has a slope of 1/3. There it is. So you could graph it, but I'm not a big fan of the graph paper. All right, we have shortcuts that are usually way faster than graph paper. Graph paper is usually the slow way. Okay, so now we're going to do a different line. This is a different line. So, I should have used blue for that one, but I didn't. Anyway, all right, for this one, we're going to subtract the y's. I'm going to do 0 minus 3. That's -3. So then I'm going to have to do -2 minus -3. -2 minus -3, same as -2 plus 3, 1. So I get -3 as the slope. So there's that one. Down 3/1. So they intersect right there. That's where they intersect. And so this is what you have to do in your homework. You find the slopes. You show me the slopes because things can look perpendicular, but they might not be. They might be 89.9 degrees. To be 90-degree angle right there, we have to know that their slopes are negative reciprocals. And so are you going to write whether they're parallel? Do these have the same slope? No. Are they perpendicular? Yes, these are perpendicular. Now, if it's neither of those things, it's not the same slope or negative reciprocals, that means they just intersect at some angle that we don't know. All right, same thing here. So let's do the first line. All right, so I'll do 6 minus 3 this time just to be different. And then I'll do 1 minus 3 for the x's. So I get 3/2, right? I don't like you to leave that negative sign down there. So this has a slope of -3/2, right? We're going down 3 and over 2. This one, subtract our y's in whatever order you want, but then whatever order, if you start with that one, you have to start with that one. Negative 2 minus negative 5, same as negative 2 plus 5, which is 3. Negative 2 minus 0 is negative 3. So this is also negative 3 halves. So what does that mean? They both have the same slope. So what does that mean? It means that they were parallel. Right? These look parallel, hopefully to you, but you know they're parallel when they have the same slope. All right, so let's find our first slopes. And so I'm going to do 3 minus 4 over, since I started with 3, I'm going to do negative 2 minus negative 4. So 3 minus 4, negative 1, negative 2 minus negative 4, same as negative 2 plus 4, positive 2. So this is, the first line has a slope of negative 1/2. The second one, all right, I'm going to do negative 3 minus negative 2, which gets me negative 1 again, right, because it's negative 3 plus 2. I started with negative 3 here, so 1 minus 4. 1 minus 4 is negative 3. I got two negatives here, so I got positive 1/3. So they have totally different slopes. They're not the same. They're not negative reciprocals. What does that mean? It means they're just intersecting. So let's see if I graphed these. Hopefully I did. There they are. So, right, there's the first one. That's the one with negative 1/2. See, it's going down. This is the one with positive 1/3. They intersect right there. They don't even intersect at a nice intersection. They just intersect at some point that has fractions in the coordinates. But they intersect right there, right? Perpendicular lines do intersect. They're just a special case. So so there's three choices: parallel and perpendicular and other intersecting lines. All right, so now find the slopes. This is I mentioned there's an exception to the negative reciprocal rule, right? This is a 90-degree angle, but these slopes are not negative reciprocals. Let's see that, right? So the horizontal line, every horizontal line has a slope of 0, right? The vertical line, every vertical line has a slope that is undefined, right? Because this one is undefined, right? When it's undefined, then the slopes are not negative reciprocals of the other. But horizontal and vertical lines always make 90-degree angles. So this is an exception to the rule, right? Because I said they have to have slopes that are negative reciprocals. What happens here is, say you take the red one, and the slope is 0/20. When you flip that over, you get this, right? But that is undefined, right? So you can't do what we did, right? And that's usually where we have exceptions in math, something with 0. All right, good luck on the homework.